We're looking at atrial natriuretic hormone, and we know that it's secreted by the right atrium when blood pressure is high. So secretion of atrial natriuretic hormone is going to cause a couple of things. Number one, it tells the kidneys to make more urine. Okay, so it tells the kidneys to make increased volume of urine. And how the kidneys make an increased amount of urine is going to increase water in the urine. That could also be said that the kidneys will secrete water. If the kidneys secrete anything, that means it goes into the urine. Number two, it's going to cause blood vessels to dilate. Vasodilation. Whenever blood vessels dilate, especially veins, they're going to hold blood. So the veins dilate. They increase in blood volume in the veins. So this is going to decrease the amount of blood to the heart. That decreases venous return. If you decrease venous return, that means that you're not putting a lot of blood into the heart, so that decreases cardiac output because what goes in must go out. And if you decrease cardiac output, then you decrease mean arterial pressure. Okay, the last one. The last one deals with the stress relaxation response. With the stress relaxation response, we're going to have a sudden loss of blood. Okay, it starts with a sudden loss of blood. A sudden loss of blood will be from probably trauma. Remember that if blood is going to be lost out of blood vessels, that's what we're talking about. So the sudden loss of blood from blood vessels. It doesn't have to be out of the whole body. It has to be out of the blood vessels, because internal bleeding means that you're going to have a sudden loss of blood from the blood vessels also. This is going to decrease the blood volume to the heart. If you decrease the blood volume to the heart, that's going to decrease the blood pressure. Okay, your body's going to try to correct that, and it's going to cause vasoconstriction. Vasoconstriction is going to try to increase the blood volume to the heart, and that will increase the blood pressure. Okay, we're going to assume that bleeding was stopped somewhere in this area with the vasoconstriction. So I'll put here bleeding stopped. Therefore, this was corrected. However, if you want to do our sign over here and say the bleeding's not stopped. If the bleeding is not stopped, then it's going to continue to decrease the blood volume, which is going to further decrease the blood pressure. This will again cause vasoconstriction. But once again, it's going to eventually cause a lower blood volume going to the heart and a lower blood pressure. Remember that force equals diameter times the pressure. Okay, so this pressure here is going to eventually get so low that the force on the blood vessel wall is low and the blood vessel is going to collapse. Remember, we talked about critical closing pressure and Laplace's law, and this is Laplace's law with the force equals diameter times the pressure. So when the blood vessels close, the heart does not receive blood. And of course, then the heart will stop beating. That's the summary of regulation of long-term regulation, part 2.